Alright, let's look at our last limit on the worksheet. It's very similar to the previous one. Look at the previous one right here. Okay, square root of x squared minus 3 minus x. But this one is square root of x squared minus 3x minus x. So let's see what's the difference. Again, quickly, let's check out what's going on. Maybe we can conclude at this point. You always have to do that to see if you can conclude, okay? So what's that? As x approaches infinity, x squared minus 3x, you remember, it behaves just like x squared. In pre-calculus, you say that a polynomial behaves at infinity as its monomial of highest degree, okay? So you have the square root of x squared minus x, you're going towards infinity, so that's about x minus x. X approaches infinity, so you have infinity minus infinity. That can go anywhere, okay? This is undeterminate, so we have to do something. So it's natural to do what we did on the previous one, so let's try to rationalize that and see where we're going, okay? So it's a limit as x approaches infinity of what? Of the square root of x squared minus 3x minus x times square root of x squared minus 3x plus x over square root of x squared minus 3x plus x. I'm rationalizing my numerator. So it is the limit. If you write equality here, you have to repeat limit, okay? As x approaches infinity of a minus b plus b, that's a squared, minus b squared over square root of x squared minus 3x plus x. So let's go ahead and cancel that, and let me rewrite my limit. So what I have is the limit as x approaches infinity of negative 3x over square root of x squared minus 3x plus x. Now at this point, let's see what we had above. Once you rationalize above, we find negative 3 over square root of x squared minus 3x plus x, and we said this will approach infinity, so it's negative 3 over infinity. Now what we have here is not the same, okay? Because if you replace again, that's an image, okay? If you replace x by infinity, this term is gonna go towards infinity. This term is gonna approach what? Infinity plus infinity, that's infinity. It's not undeterminate, it's infinity. And you have infinity divided by infinity, and this is exactly the same as 0 divided by 0. It is undeterminated. So we are on the right track, but we're not done because we have not lifted up our undetermination. We need to go further, okay? So the top goes towards infinity and the bottom approaches infinity. What's the problem here? How can I get rid of this infinity at the top if I can? Let me factor x, and I'm gonna factor x out of that. So you need to remember your algebra right here. Here, before I factor x, let me take it out of the denominator. It's gonna be the trickiest part. Over. Now, let me take x out of this root. I'll do it in 2 steps, okay? So take an x squared right here. X squared times what? Times 1 minus 3 over x, right? And let's keep this there. I know what I want to do. I'm gonna try to factor x to simplify this fraction, but before I do that, I need to work on my radical here. Now, look, this is the root of a product. It's a product of the root. And in this case, again, I'm going to simplify square root of x squared as x. You know, normally you have an absolute value, right? But x is approaching infinity. That means x is positive. And so the absolute value disappear, okay? And it's just a square root of x squared, it's just x. So, what do I have? I have the limit as x approaches infinity of negative 3x divided by, now, x goes out, so it's x times square root of 1 minus 3 over x plus x. Alright, let's factor this x as the denominator. Limit as x approaches infinity of negative 3x divided by x times, okay, let's see here, square root of 1 minus 3 over x plus 1. Here we are going to simplify by x, and now let's see where we are. We have limit as x approaches infinity of negative 3, hey cool, no more x's here, over square root of 1 minus 3 to the x plus 1. So what's going on here? X is approaching infinity. So 3 divided by x, if x gets very large, 3 over x is approaching 0. So 1 minus 3 over x, 1 minus 0 is approaching 1. Square root of 1 is approaching 1, okay? 1 plus 1 is 2, and so I believe my limit right here is going to be negative 3/2. You see? It's not 0 anymore, it's a different one. Let's check it out with the calculator, okay? Remember? Okay, so let's go back to the Y editor screen. Oops, just a Y editor screen right here. And here, what I want to do right here is just introduce an x. So insert x right here, and that should do it. Okay, let's check out the table of value again. Table of value, and now you can see, you know, 100, it's negative 1.511 here. I mean, if you want more precision, you gotta see it, you get more precise here. Negative 1.5011, negative 1.500, okay, and let's do one last one, why not very big. So the last one was 10,000, so let's take 1, 2, 3, 1, 2, 3, 1, 2, 3, 1 million, right? I think 30 right here and 30 right here. Yeah, that's sorry 1 billion. And let's push enter, and it is well, the calculator is telling me it's negative 1.5. Okay, so for the calculator, this huge number 1 billion is infinity for the calculator. Okay, so this little calculator thing does confirm that the limit is negative 3/2. What's going on here intuitively? Well, intuitively, if you remember earlier, I told you that the strength with which this term is approached to infinity is exactly the same as this one. Well, I would say, I guess right here, it's the same strength, but there's a little difference. The limit is no longer 0. They don't completely cancel each other. There is a tiny bit above right here. There's a tiny bit more strength right here. So the limit is what is it? Negative 3/2, right? Yeah, negative 3/2. That's how I would look at it. And I think it's okay to say it like that. Okay. All right. Bye.